بس لحظة. Okay. Now you can see my slides, right? You see my slides? Hello?
Yes.
Great. Now, power electronics, okay? Today we will give introduction to the topic. What is power electronics? So in this week, we have two topics to cover. Power electronics as a fundamental of power electronics. What is the subject? What is the topic? What it contains? And the second issue is the semiconductor devices. Okay, I will revise what you already studied in different courses related to semiconductor switches. Okay, now first of all, you remember what we have is AC and DC. Sorry, AC and DC. We discussed the definition of AC and DC, if you remember, in level 2. DC is direct current, where the current is either positive or negative. It cannot fluctuate between positive and negative. It could be positive but fluctuated one. It could be negative but fluctuated, but fluctuating between positive and negative is not allowed. While AC, example is the battery. You remember, this is the battery. If this is the voltage or current, this is the current, and this is the time. This is a DC current. This is DC because it's still in positive. This is DC current, still in positive, but fluctuated, not pure. While when it comes to AC, okay, as example sinusoidal, you can see there is positive part, negative part. Square wave is also AC. Okay. Now power electronic, we have 4 circuits, main circuits in power electronic, which we are going to discuss this semester. These circuits convert from one form into another form. Why? I will say why. But first of all, we will convert from AC to DC, from DC to AC, from AC to AC, from DC to DC, 4 converters. Now, why we convert? We convert because our demand, our load, sometimes you have AC supply, but your load is DC, you need to convert. Vice versa, if you have DC and the load is AC, you need to convert. What I mean of AC, DC, DC, you have a battery, let me say 12 volt. But your let me say device, you have a radio as example, or let me say tab, or you have laptop you want to charge. You need to charge with 5 volt, but the supply is 12 volt. So what should you do? You use DC, which convert the 12 volt into 5 volt. Or let me say you have a 12 volt input supply, and the device you use need 18 volt. You need to improve it, right? But it's still DC. So DC to DC. So converting from DC within specifications into another DC with higher or lower specifications, this is called DC convert. The same thing for AC. You have 230 volt AC frequency, 50 hertz in Oman, but you need to supply load with 50 volt AC. With the frequency not 50 hertz, 200 hertz as example. So these are AC to AC converter circuits. Now, so simply if we want to discuss the process of these converters, we will say we have power input. As example, in Oman, we have 230 volt, 50 hertz. We have voltage input, we have current input, and our load need voltage output, current output, right? Now here is the converter, the power processor, which converts this input into this output. Okay, what is inside one of these circuits, or maybe more than one at the same time, as we are going to show. Definitely, to make a control on this, because here a power process, it means there is control inside. To control this, we need negative feedback, as you learn in control. Compare with a reference, if it is voltage, if it is current, if it is power, if it is whatever it is. And then it go to the control circuits here to control the process. Very simple circuit, input, output, and control. So if I come to define power electronics, it's the electronic circuits which convert the power using control. So it's marriage between power, electronics, and control. Okay, as we are going to see. Now, in the past, talking about the old days, you remember, anybody remember the large TV we have at home, talking about 20 years back, maybe? No, you are still young. Okay, not 20 years. Anyway, there is the old bulky TV available at our homes, okay, in the past. Today, it's a flat LCD, or let me say plasma. There is a flat screen monitor. But at that time, it's large, big, all devices, all equipment and appliances we use at home are large, okay? These devices use what we call it power supply, line power supply. What is linear power supply? What is linear power supply? Have a look. Here we have 230 volts. It comes to a transformer. Transformer make my device large because which large transformer take place. Why transformer? To step it down, let me say, reduce the voltage into 12 volt. Still AC. Here AC, here AC. Okay. Now we put here rectifier circuit. You remember in level 2 when we talk about rectifier, we use diodes. Okay, 2 diodes or 4 diodes to rectify it, to convert it from rather than the supply voltage in this way. Okay, if you remember, we rectified it to become in this way. You remember this? We mentioned for this circuit at that time also. So here it's just a block with a diode. It could be 2 diodes, 1 diode, 2 diodes, 4 diodes, 6 diodes, and so on. Anyway, here we use capacitor. Now let me ask this question to see if you remember what we discussed last year or you forget. Do you remember in 2019, first semester? Capacitor, it's a storage element. It's used to smooth which one, voltage or current? Who's remember? Who remember this? Capacitor. Voltage. Excellent, voltage. Excellent. You remember, great. So it's smooth the voltage. The voltage should be in this way. But when it gets smooth, it becomes in this way. As you can see here in this figure. See? Now here we have, at this point in the circuit, we have voltage similar to this one or this one here. Okay? And then we use a transistor connected to the load. This is transistor work as a variable resistance. It means it work in active region. You remember, in active region as an amplifier, a variable resistance. When we say variable resistance, it means we have a drop here. We have losses here, right? Because like resistance. So we control the voltage across the output by control the transistor. We control the base. We control the output. That's it. Very easy. But what is the problem of the circuit? We have a few problems. The first problem, the size is bulky. Why? Because we use a transformer. Okay. The second issue, losses is high. Losses in the transformer, losses in the resistance here, which mean the transistor. Okay. So the efficiency will be low. Okay. So size, large in size, heavy in weight, more power losses, less efficiency. All this is part of the old days. We don't want it. We don't want our systems to be like this. We want to be more better, consume less power with high efficiency, low, small in size, small in weight. Their weight and size is small. I will show you how we change this way. Let me say of this trend of our supplies into another trend which use power electronic converters. So this linear power supply. Now this is just to give you a brief about the history of power electronics. It started in 1900s, and it was vacuum. They use mercury vacuum tube. I don't know if you saw it. It's not available today in the market. In the museum, maybe you find something. If you Google it, you will find some photos or videos talking about this that time. 1957, if you remember, I talk about three scientists in level 2, Shockley, Berdeen, Aberdeen. They invented the thyristor, okay? They invented the thyristor and the power diodes, okay? So here there's a huge important step started where the converters was changed, and then more improvement in semiconductor devices, especially the thyristor going on. So it's improve our circuits. Okay. Thank you. And then GTO, IGBT, as I'm gonna talk about them, gate turning off thyristor, isolated gate bipolar transistor, and other devices came to improve this, let me say, topic. But the applications are wide, as I'm gonna show you. Today I will focus more on applications. As you can see here, you can see rolling mills, elevators, industry, in renewable energy, in wind, in construction, in smart grid, in air conditioning, computer, vacuum. Oh, there is a wide range of application, as I explained to you. But before this, let me take you to how we improve the linear power supply. I just discussed the heavy one, the bulky one, the less efficiency one, with what we call it switch mode power supply, which use our power electron converters, what we are going to discuss this semester. Have a look here. Still the 230 here, but we will not use transformer. Directly it will go to the rectifier and the capacitor as smooth. Now here, this part, I put circuit. And here, I will talk about the circuit. Here, filter, inductance, capacitor, inductance for low pass filter to smooth the current, capacitor to smooth the voltage, and this is my load, the same load. But this circuit here, as you can see, transistor here, diode here, transformer with 3 windings. What is this dot? What is this? Why this diode? This is what we are going to discuss. This circuit, we will mention to part of it in different places through the semester. I don't want to discuss it now. Okay? But what I will do, the function of this circuit, okay, simplify here. The same, this is the same load and the same filter. But the circuit, all this part was simplified here in diode, transistor, and DC supply. Okay? More simplifications occurred. Now, this is the final shape of the circuit. Because what I want to do here is to explain to you how we control the as example, DC to DC. In the previous circuit, we have AC, we convert it into DC, and then we control it to supply the load. This is my load, and this is the filter, low pass filter. Now here we have DC supply. In the previous slide, the transistor and diode and the transformer with the 3 winding working this way, like a switch. Either it is on A, so the circuit close, and the current will follow here, and we have a closed circuit. Or it will be on B, the supply will not be anymore available, and we have only inductance in parallel with capacitor with the load. Now this circuit, if we come to the voltage here applied across the filter and the load, we will see it is either when the transistor is on, okay, the circuit is a closed circuit and the voltage here appear across the load. This is the voltage. When the switch is on B, 0 voltage will appear. And again, it's repeat itself. What happened here? We have T on and T off. What is this T on and T off? T on when we control the switch, the transistor, to be on. And T off when we switch it off.